Hello, everyone, and welcome to Science Explosion. My name is Zach, and I am coming at you from Hudson Public Library. For anyone not watching this from our little town, that is in Hudson, Iowa. So thank you so much for joining me. Today, we are going to be talking about mountains. All right, so let's start off with the basics. What is a mountain? I'm going to show you. All right, so for this demonstration, if you want to do it yourself, it is very simple. All you need is a stack of towels or washcloths. All right, so grab it by both ends, or you can put it between some things, and then you are going to squeeze it together in any way that you want. So you're starting to notice that there are some lumps in this when you squeeze it together. So the way that I'm squeezing this is very similar to the way that mountains get formed. So mountains are huge piles of the Earth's crust, and they jut out of the land and they rise up high. So without thinking about what a mountain is, you probably already know that it's something very tall. It sticks out. So the opposite of what a ravine or a valley is going to be. They're way up high. And this is exactly, or pretty similar to the way that it works. There are forces that are pushing it up. And why does that happen? So I'm going to show you something else that'll help to illustrate that point. And that is right behind the computer here. And that is a gobstopper. So I smashed one of these open so that I could show you that this is actually a pretty decent model of the Earth. All right, so if you can see right there. So if you've ever had gobstoppers or any other type of jawbreaker, you'll know on the outside, there are a few small, thin layers of hard shell candy, and then inside it is, well, in a gobstopper, it's kind of a chalky type candy, and this is a lot like how the Earth works. So the Earth, most of the inside of the Earth, just like most of this gobstopper, is the kind of chewy, chalky candy. Most of the inside of the Earth is going to be magma. And so that is liquid rocks. And so that's going to be the bulk of what it is inside there. And so even though all of us and every living thing lives on the crust of the Earth, it's a teeny tiny little shell, just like on this gobstopper. So I'm going to try to hold it still so you can see it clearly here. So this little shell right here is a lot like the crust of the Earth. So think about it like if you have some dough for some bread. If you leave it sit out for a while, you'll notice that the majority of the dough is kind of liquidy, but if you leave it out, there's a crust that forms on top. That's actually a lot like how the Earth works. It's not like we just left the Earth out too long and it started to form a crust, but you get the basic idea for that. So the difference between the Earth, though, and this gobstopper is that the gobstopper, the crust is pretty much just in one place there. Until I start to eat this, it's just gonna stay like that. But the Earth is so much more interesting than that. So the crust of the Earth isn't one solid piece like this gobstopper is. Instead, it's a lot of different pieces. And the cool thing is that they're always moving around. So they're always moving towards each other or towards each other or away from each other or against each other. And that's how we get so many cool things that form on the Earth. So a mountain is when two pieces of the crust are pushing up against each other. And just like me pushing up against this stack of towels, they'll push the land together, and then in parts of that land, it's going to get pushed up. So if you think of a mountain, like a really, really big mountain, like Everest. Everest is the tallest mountain on Earth, and that's how it formed, is two pieces of land pushing into each other, and then, ooh, that popped my fingers a little, pushing into each other, and then forcing that land to go higher and higher. And actually, if anybody ever has plans to go on to Everest, it's good to know that it actually gets taller every year. This isn't just something from the distant past. This is always happening. Not by much. I believe it's only like an inch or two every year. But it's still a difference. So if you were to go to Everest this year and the next year, you'd actually be higher up next year when you did it. But we think our Everest is impressive, but there's a lot more impressive mountains out there. In fact, even on Earth. So we're used to calling Everest the tallest mountain, but there are a lot taller mountains and mountain ranges under the ocean. Problem is, we don't really see those. But the largest mountain in our solar system is on our neighbor planet. It's on Mars, and that is Olympus Mons, and it is a massive mountain. Alrighty, so I think that gives you a little bit of a sense there of kind of how mountains get formed. This will also show you how things like valleys get formed. So if I were to adjust this again and then do it in just a little bit different way, you can see now I've got a mountain on this side here, and then right here, I've got a valley. So that's gonna happen in much the same way. It gets pushed on that, and one part raises, and then another part ends up getting bowed down. Alrighty, I'm gonna set these over here now. All right, so now that we talked a little bit about how a mountain forms, we're gonna start to talk about a specific really cool thing of how people measure mountains. By the way, those other ways that the tectonic plates, so remember those are the plates of the Earth's crust, move against each other are really interesting too. When they move apart, that creates some really cool things of land forming in between those. And when they move against each other, that can actually cause quite a lot of damage with earthquakes and things like that. That's actually why there's that huge fault line in the San Andreas Fault. So just so you know, that's really interesting, I think. All right, so we're gonna get to the main part of today's experiment. So what you will need to follow along with this, and keep in mind this is online, so you can pause this and come back at any time. You'll need a bowl for mixing your things. You're gonna need some flour. I just have plain old flour here. If you have any special kinds, you can use that too, but I think just good old cheap flour is the best way to go. You're gonna need some oil. So I just have vegetable oil here. Olive oil would work just as well. All right, you are going to then need some water to add to this. All right, and then the one thing that would make this work even better to mix in is cream of tartar. And I don't have that here, and I'm guessing a lot of people don't at home. So I'm going to be doing that just with these ingredients. But if you have cream of tartar, you're gonna wanna mix that in because it's gonna make this bind even better. But I'm trying to just have things for what I think most people at home would already kind of have on hand. So this recipe that we are making here is actually for Play-Doh. So the cream of tartar keeps it together and helps it to become a dough. But for what we're doing today for this, I think this will work just fine. All right, so the other things you're gonna wanna have with you are a sheet of paper, a pencil, and 2 rulers, or at least 1 ruler and a stick to tie it to. And then you'll want some string. String, yarn, dental floss, anything like that should work fine. Alrighty, so let's get started on this. So I'm going to show you how people measure mountains. And it's a pretty cool way to do this. So the science of today, we talked a little bit about geology, but now we're gonna get into cartography, and that's the science of map making. So that's a little bit of a hint of what is coming up next. All right, so I'm gonna read off the ingredient list for you here. So if you want to make it actually like Play-Doh, you're going to want to follow the recipe pretty exactly. And just a heads up, this can get a little bit messy, this recipe, so just be aware. All right, so you're going to need 600 grams, so that's by weight, of flour. You're going to need 300 milliliters of water. You're going to need 100 milliliters of vegetable oil. You're going to need 2 tablespoons of cream of tartar, 1 tablespoon, teaspoon of salt. Oh, I forgot to mention, there's also salt. Sorry about that. And then you'll need a mixing bowl and a spoon. I think you can do it with your hands, though. That's my personal opinion. All right, so if you are not following along to make your own dough, then for what we're doing, you can do it how I'm doing this, and I'm going to eyeball it. So when somebody says they're eyeballing a recipe, that means they're just looking at it and kind of guessing on what the right measurements are. Because I'm not actually going to be making this into a dough, I just need it to hold up well enough. So if you're making it like me, then you can follow along. So if you're making the dough, then you'll use the exact recipe, but if you're following along with me, just kind of watch and see how I do it. So you're gonna pour in, I would say, you won't need more than 1.5 cups to 2 cups of dough. You could make it smaller, you could make it larger. That's going to depend on the size of your mountain. So we are building a mountain out of these ingredients here. All right, so next, this oil is going to help it to stay together a little bit. And you're going to pour, I'd say about a spoonful in there will be fine. Maybe a little more. That's the nice thing about eyeballing things. You can always just add a little bit more or a little bit less later. All right, grabbing the salt. I'd say if you're doing a shaker like I am, with an open mouth, 3 healthy shakes. If you're doing a closed salt shaker, I would say, or a small salt shaker with small holes, I would say give it a shake for, I'd say, probably about 3 seconds. And then you're gonna pour in about twice as much water, I'd say, as you did oil. All right, this is looking beautiful. So that's what we've got here. And I'm gonna start mixing that up with my hands. This recipe called for using a spoon, but I think it's so much more fun to just use your hands. So, if it is too powdery, like mine is looking like it's going to be, that is okay, because you can keep adding more water until it becomes a thick dough. I would say it's a lot easier to add in water and oil than it is to keep adding in more dough. I'm gonna add some more of that in. We want a really thick dough. We don't want this to settle at all. So it's gonna barely stop being a powder when you get that mixed in. All right, so let's see. We're getting that mixed up all nice here. Starting to smell good too. So I bet you didn't know that it was actually quite this easy to make your own Play-Doh. The only thing that I think most people might not have in their homes, and a fair number of you might, though, is the cream of tartar. That gets used for cooking. And all right, this is starting to come together. It's just a little flaky, almost staying together, so I need to add just a tiny bit more water. And I'll stir that up. You want it to hold together though. If it's starting to fall apart, then we won't be able to get our measurement quite right. All right. keep mixing that up. See, you'd miss so much of this if you're using a spoon. You're welcome to, but I think it's fun to mix this up by hand. So the cream of tartar is going to help this to set, or not to set, to bind together, and it's also going to help this to not dry out quite as much. That's another reason why the oil is in there too. All right. Beautiful. This is starting to come together really nicely. So I'm going to shape this. All right, so now you can knead it with your hands. I think all the best bread kneading is done by hand, my personal opinion. It's always important to distinguish between facts and opinions. Me saying that I think it's better to mix this by hand and to knead it by hand is my opinion. You might have a different one, and that's all right. All right, so we've got a nice lump of dough here. If I hold it like that, it's not slumping in my hands. That's what you need. It should hold its shape pretty well. All right, so now I'm going to set my water to the side here, and you're going to need to grab your piece of paper. I'm using a sheet of construction paper because it's a little more sturdy. But if you have just a regular sheet of paper, that is fine. So you're going to divide this up into, ooh, I grabbed a few more pieces of paper than I meant to. You're going to divide this up into 4. So you could measure this with a ruler, which is actually what the instructions said to do for this one. But I think it makes a lot more sense to fold it and use that as your measurement. So fold it in half, hamburger style, unfold it, and then fold it hot dog style. Do people still say it like that? That's how my teachers always said it to me. All right, so now you've got some vague lines right there where you folded it. To make this a little bit easier to see, I'm going to grab my pencil. If you don't have a pencil, a pen will work fine too. And then I'm going to take my pencil and run it along those lines. So now your paper should look like that. Perfect. So these right here are your cardinal points. So that is just like using a compass. So north, south, east, and west. And you could even label that if you want to. It might actually help you to keep it steady. So what I'm going to do is write an N on the top for north. All right, so now that you've got that, you're going to take your dough, and right now it's a little bit of a blob, and that's not really what most mountains look like, is a blob. So instead, I want you to shape that into looking a lot more like a mountain. It could be a tall mountain, it could be a short mountain, you could even make some paths on it if you want to, but it should look a little bit like an upside down ice cream cone. It could be pointy on top, it could be rounded on top, you could even have a hole in it on top like a volcano. All right, so then you're going to take that and plop it right down in the middle of your piece of paper. All right, and then there's a few ways to do the next part, but you're going to want to make a mark so it's obvious which side is facing north. So to make that easier on myself, I just made a little divot there, just so I can always line it up that way. And then I followed my divot, making an indent all the way up to the top. So that way, I am always going to make sure that that side is facing the same way. That's really important here. Okay, so you've got that. Now you're going to want to grab your 2 rulers. And your string. All right, I've got this nice shiny string because I thought it'd show up well on the camera. And you're going to tie it to your 2 rulers at the same height. So my rulers aren't the same height. That doesn't really matter. It's just my string needs to be tied at the same height on there. So I'm going to tie it on the first one. And let's do 2 centimeters. Looks like a really good height for that. Actually, there's a divot in here, so I'm going to do at 2.5 centimeters, so I'm going to do that. You can use inches if you want, but I always encourage everyone to, if you're wanting to get into science, measure things in centimeters, meters, in that style, because that is the international standards for scientific measurement. So even though here in the US, we use a different measurement system, and that's fine. If you're doing things in science, you're usually going to be measuring them not in what we have is called the imperial system. All right. Ooh, this is a thin string. This is harder to tie than I thought it was going to be, but that's okay. I can hold it. So I've got it there, and then I'm going to tie it at the same height on my other ruler. So you're definitely going to want these to be the same height because it is going to need to be level. And let me see here. I think I'll just wrap this one around so that I can get this going. All right, so this is what you'll have. And you can do this on sticks too. I just think it works really well if you're using a ruler because it will help you to get a measurement of what your scale is. So mine is 2.5 centimeters. So I'm going to write that on my paper. All right, and so now you've got your mountain on there, and I want you to take your pencil and trace around your mountain. Now your dough is soft, and so you're going to want to be careful not to jab your pencil into your dough. There we go. So I'm going to lift this off. So this is what you see on there. Now it's starting to get the paper a little wet, which is why I picked construction paper, but if you don't, it should still hold up pretty well. And so you can see if I put this back on there, it lines up right where that is. All right, so now the fun part. You're going to take your string, put it right over your mountain. You're going to wrap your string around, and you're going to cut with your string. And it might be a little hard, but that's okay. You're going to pull it through your mountain. And you can take it slow if you need to. All right. So what you're doing is separating off a layer from your mountain. Alrighty, here, mountain. You're almost there, almost, and there we go, we got it. So now I cut off this, and this is the bottom half. This right here is the bottom, and you can see that they used to go together. So this is why it's important that I marked all the way up. You'll see in just a second. So now, keep where your mark is pointing north, put it back on your paper. You're going to want to make sure to put it down right in the middle of where it is. So if you can line it up right with that point, the top of your mountain where it was. So now you can see the outline outside and now this higher section of the mountain. So now I'm going to trace around this one again. So trace, 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 taking my pencil, tracing it around. All right, so now I'm going to lift this up to show you this is now what the second part of this is. Can you guess what we're going to do next? All right, so if you happen to guess that next we're going to do the same thing and cut it off one more time, then you were right. So see, going to put that right on there so you can kind of see it. Let's see, I'll hold this up a little bit better. So see, I'm holding that there. You can see where that is. My other ruler fell, so I need to reattach that, but that's okay. All right, so now you're going to slice this across. So I'll show you this time when I'm about halfway through it. And depending on how tall your mountain is and how big your scale is, you're going to need to do this a few different times. So I'm going to cut off my mountain. And be careful not to squeeze it too much, otherwise you'll change the shape of your mountain. All right, so I'm going to show you. So see, I'm halfway through pulling that through the mountain. Now I'm just going to keep working its way through here. Keep pulling it. And you'll probably want to go a little slower than I am because I just changed the shape of my mountain just a little bit and I did not mean to. And there we go. Now this top part is less than 2.5 centimeters, so I'm only going to have 3 lines, but that is a-okay. So I'm going to put that down in the center so you can see that's what this part looks like. So you can see my other 2 lines there. And then I'm going to trace this one. So tracing around this one. And there we go. So I know that's a little bit light, but you should be able to see. This is the outline of the bottom of the mountain. This is the middle, and then this is even farther up. So we have just made a topographical map. So topographical, I know that's a bit of a long word. It comes from topography, which is a measure of the surface of things. And so we can see now that I've put my pieces of the mountain back together, I still have my original mountain, more or less. And but now I have a map that can show me exactly where it is. So this is, if you've been following along, we've made a map for ourselves. So this is north, which most maps are going to point at the top of the map is north, just to standardize that. So standardizing something is making something so it's the same across the field. Then in the bottom corner here, I wrote 2.5 centimeters because that's how much distance between my lines I have as far as height goes. So if you ever see a map with these wavy lines everywhere, that's a topographical map, and it's telling you how to read the elevation or how high something is. And there are times where it'll go back down below, and something like this, if we were doing it detailed, since I did make it a volcano style, it is going to go back down lower. So if I had made this smaller distance measuring this than 2.5 centimeters, I would have a lot more lines on this. And that's what a lot of topographical maps do look like. And they're going to have a lot more details. But just as an explanation, I'm going to show you just with 3 cuttings of this. If you're doing it yourself and you want a bit more of a challenge, then I would definitely recommend that you do it a lower interval. So mine was yay big. I would say go that, and you'll have more lines on there, and there'll be a lot more detail. You'll just need to write down at the bottom what the interval is. So by looking at this, if you know how to read this kind of map, and I think this is going to make it a lot easier because I know those maps can be confusing for a lot of people. If you look at this, you can say, oh, I see that this is a single mountain in here, and I can see that between this line and this line, it's gone up 2.5 centimeters. So looking at this, I can tell what this mountain looks like. Now, when people are making these types of maps of real mountains, they're obviously not slicing up part of the mountain, but what they are doing is they would walk up to this point of the mountain, and then they would take a measurement here, and then they would do it all around that mountain. Or now they would just use really high-tech surveying equipment. But you could do this yourself if you wanted to make a topographical map of Hudson, or if you're watching this from somewhere else, wherever you are, you would just need to know how high you are and then make marks along there for what the different changes are. And so if this was a whole range of mountains, so let's say you made 5 of these and put them all over your piece of paper, you would slice each one at the same level and put it all around. So maybe I've got a shorter mountain here, and it would just have, let's say, this line here, just like this one does. Maybe it's got a really similar base here, that. But then let's say that maybe it's just got a smaller center and it's a pretty flat mountain, then you put that inside of it, is what it would end up looking like. But yeah, so this is a 2D representation of a 3D object. It's pretty cool. Just like if you have gone to art class and they tell you how to draw a cube in 3D, this is really similar to that kind of thing. It's really hard to draw something in 3D on a little 2D piece of paper. And so map makers got really clever and creative with this and figured out a way to show how high a mountain gets and how quickly it gets that high. Alrighty, so that is just real quick how to make your own cartographic map and then kind of how to read those. So just remember, between those lines is that change in elevation, and elevation is just how much it's changed how tall it is. So looking at this, I can tell that this is the same as this mountain. I think that's pretty cool. So now you've learned a new skill, a new science. And by the way, there is a technical name for these lines. They are called contour lines. If you're wanting to sound technical on this, and I always think it's fun to know these types of technical terms, but I think understanding what they are is always going to be the most important part of any type of learning for this. So thank you so much for joining me for Science Explosion at Hudson Public Library digitally. My name is Zach, and thank you so much for joining me. And next time we're going to be talking about fire. I think it's going to be a lot of fun. Thank you so much. Bye.